Okay, everybody, let's recap the lesson. So we started talking about radians, and what we like about radians is that if you have an angle, then the angle is related to the arc length. So today what we want to talk about specifically is arc length. We use the symbol S for arc length, and area of the sector. We use K to be the area of the sector. Now, because we have two ways to describe angles, we have either degrees or radians. They're really kind of two formulas. Well, actually, the conversion of the formulas in here. So if you have an arc length and your angle is given to you in degrees, it's just theta over 180 pi r. And I got all of these formulas from page 263 out of your book. If the arc length, if your angle is given in terms of radians, just S equals r theta. Then we can also find the area of a sector. And again, if your angle is given to you in degrees, then it's just theta over 360 pi r squared, which is a fraction of what circle? Area of a circle. If your angle is given to you in radians, you want to find the area of the sector. It's just K, which is area, 1/2 r squared theta. Now there's one more formula which kind of makes sense, and that is if you know a radius and an arc length, it creates only one sector, and so you don't need the angle, but it's just K equals 1/2 rs. Okay, so example one, we're given the angle in degrees, and we want to find the arc length, so we use this formula here. So it's just 110 over 180 pi r squared, or pi r, and all I did was use my calculator, and I got an answer of about 11.52. If I want to find the area, again, my angle's in degrees, so I use this formula. I went theta over 360, or 110 over 360 pi r squared, used my calculator, and I got the answer in terms of centimeters squared. Pretty easy. Example two is a little bit backwards, more like Jeopardy, where you're given the answer, you've got the area, and you want to come up and find the radius and the central angle. So what I know, I like to write what I know. What I know is the arc length is 6 and the area is 75. So I'm looking for a formula first. So the easiest formula to use is this one here, S equals r theta. So then I put my 6 here, my 25 here, and I got my angle. Now that is an angle. 0.24 is an angle in terms of radius. Remember, if pi is 3.14, that's an angle, okay? And then I need the area, and then I just used this formula, it's the easiest one to use. So I used 75 equals 1/2 r times 6, because that's my my radius, or my arc length, and then I found the radius to be about 25 centimeters. Okay, so I'm just using my formulas. On the back side, number 3, again, this is a little bit like Jeopardy. I like to write what I know. I know that K is 25, that's my area by sector. And I have an angle of 1.5 radians. That is an angle. Okay, so then if I need the radius, I use this formula because I know the area and I know the radius, and I was able to then, or I'm sorry, I know the area and I know the angle, and I was able to plug those in. 25 here, 1.5 for the angle. I was able to solve for r, and I got r to be about 5.77. Right, divide by 0.75, square root. There's my r. Once I knew that, then if I wanted to find my S, I just use the easy formula, S equals r theta. I know the radius now, I know the angle, and then the arc length is about 8.66. Okay, example 4 is an unusual question. If you were to think about this gigantic circle, here you are at Earth, looking at this tiny little planet, Jupiter, and then you think about a gigantic circle that goes all the way around you, that the arc length of that gigantic circle is almost flat at this point, right, because it's such a big circle. So we can almost estimate the diameter, because it's pretty close to flat, as the arc length. So just use the arc length formula. I know that S is equal to theta over 180 pi r. The radius is the distance to the planet because of the giant circle, and then that is going to be 8 times 10 to the 8th. And the angle, because it's just a little itty-bitty angle, right, its apparent size is 0.1. I just used my calculator, and I wound up with 139,626 kilometers. Estimate of the diameter of Jupiter. That's all I have. There's your homework for today, and we'll talk about it tomorrow.